All right. Hi, everybody. We are starting our community development corner. Today, we are going to have CharlieFrick from Open Cybersecurity Alliance within OASIS, and he is the chair of the Indicators of Behavior work. Hi, Charlie.
Hello, Marlon. Thank you for having me. So welcome. Thank you for again, everybody. Like I said, my name is CharlieFrick. I'm from Johns Hopkins Applied Physics Lab, and I'd like to talk to you today about the Indicator of Behavior Sub-Project of the Open Cybersecurity Alliance. Let me see if I don't know if I need to be made a co-host or not, but I think I do in order to share the slides.
Exactly. I think I can't do that for you right now. I don't have the ability to make other co-hosts. Jane, would you be able to make Charlie co-host? There we go.
Yep, I just did.
Thank you, Jane. So let me start my screen share. Hopefully, everyone can see those slides.
Yes, we are seeing them, Charlie.
All righty. Thank you, Jane. Oh, there we go. Okay, so I'll kind of step through here, but I want to make sure to leave time to answer any questions we might have at the end. But in general, we here at the Applied Physics Lab have been partnering with CISA for many years on projects related to cyber threat information sharing and security automation. And in 2021, we both partnered with the Open Cybersecurity Alliance when they established the Indicator Behavior Sub-Project. So, and I'll talk to you some about what we're doing and why we saw the need for it, and some interesting ways that we think that we've been using STIX and a few other standards. For more information, you can always go to the IoB website on opencybersecurityalliance.org/IoB, and we can make these slides available to everybody. They're on our GitHub right now. But I'll start with the motivation for the research. As I said, we've done a lot of work in security automation, and frankly, we've done many cases of how to automate the use of indicators of compromise. And I think what many of us all will acknowledge is that indicators of compromise are not sufficient for many of our security use cases. They're reactive in nature, they're not very repeatable, and they have extremely short times when they can be used. So we were looking to find ways to share more actionable types of intel, and not just actionable in that someone could read it and think and design a customized detection, but we want it more actionable and that it could be processed by automation as well as by people. And we find STIX is a very great standard for passing machine readable threat intel. And we also are really grateful for MITRE ATT&CK and defend, but the problem we see is attack and defend are at the technique level. So that makes them a little higher level than what a piece of automation or a general user can do. I can't build a detection for every instance of an entry and attack. There's too many because it's at the technique level. And so we wanted to look at how could we represent sequences of procedures that were repeatable. And that led us to understanding that we really needed a machine readable object that could represent what the adversary is doing in a way that's a little bit more specific than what we find in an attack, but still higher level and repeatable as compared to an indicator of compromise. And that led us to representations of adversary behavior or indicators of behavior. And the way I like to describe it is, if I think of this sequence of green boxes in the middle, a machine on my network opened a potentially suspicious email. I normally wouldn't share a detection for that alone because it would have a high false positive rate. A machine on my network runs PowerShell for the first time. Again, don't normally want detections focused there because the false alarms are too high. The machine has a program modify the registry and a system level process that's sending suspicious traffic. We don't see the detections for things like this being shared because, again, people feel that their false positives are too high. What we wanted to think about, though, is instead of focusing on those detections, if we were to let those detections be processed by automation and really focus on correlations. So rather than search for a specific hash or a specific registry key, what I really want to know is, did the computer that opened a suspicious email download an attachment? And did the attachment that was downloaded start PowerShell? And did that session of PowerShell modify the registry? And so on. If I can start sending a correlation for those detections that by themselves have high false positives, I start to get a low false positive sequence of behaviors. And if I design the detections right, these can be repeatable regardless of campaign, because it's based on the behavioral observations on my network. So that led us to wanting to build the indicators of behavior. Now, this is an overview presentation I normally give for describing the IoB to many audiences. Since this is the CTI TC, I won't explain to you what sticks and taxi are because you guys made them or maintained them. But I did want to take you through a conceptual example of the type of information that we're holding, and then discuss in a little bit more detail some of the things we have available on our GitHub if you'd like to learn more. So here, what I'm showing is we have some custom Stix domain objects and extensions for representing the behaviors. So receiving a fish, downloading a macro, and strange DNS traffic. And those behaviors, I can have relationships to tie them back to standard Stix attack pattern objects. We normally do use the MITRE attack Stix repository. And we can also include Stix cyber observables to share how we came up with the idea of representing this behavior. But we do a little bit more than that. We also create an extension for detection objects. And these are linked to the behaviors, and they are ways to share an analytic for detecting that behavior. That analytic could be Sigma, could be a Stix pattern, could be Stix shifter, could be SQL, could be all sorts of ways that one might search for that behavior. Most of our examples, we tend to use Sigma or Stix shifter for ours because we want queries that can be repeatable and also can translate to many different production environments when it comes to tools like Seam. But again, the idea is for these to be run in the background. And then we also share a correlation workflow so that you could design a way to correlate your alerts, either through your Seam, through a SOAR, manually if somebody really, really, really wanted to do that. And yes, and Terry, I definitely want to talk to you more about that during the Q&A. But this lets us, correlate the objects. We have examples where we've used BPMN, Cacao, and Kestrel for those correlations. Then, once you've correlated an adversary's activity, we then could use that to share a course of action to take in response. And related to that is a playbook object where we can embed a security playbook. Most of our examples are in Cacao right now. Also want to give thanks to Dr. Vasilios Mavridis over at University of Oslo, who helped talk us through some ideas on how to embed the Cacao playbooks inside Stix. But if we're thinking about sharing this, we also want to use a Stix grouping object, because I've been conversationally saying bundle, but I do understand that the Stix bundle construct doesn't necessarily always make it through all infrastructures. So we want to use a Stix grouping object to let receiving automation and audiences know what elements are intended to be shared, as well as your standard identities, extension definitions, all the standard objects you might want as well connected to this data. So that's the overall concept. But what we've built on the GitHub is a reference implementation prototype that we wanted something that had a little bit more depth so people could experiment and find, give us some useful feedback on all the different elements of this concept. So it's several thousand line JSON bundle. It's compliant and validated with STIX 2.1. And we based this off an emulated attack of APT37 or Reaper. And when I say emulated attack, what we did in our research environment, we built a very tiny artificial enterprise network, about a dozen machines, few different email, domain controllers, a few different file servers, firewalls, and instrument and collected Microsoft Sysmon to a SIEM, as well as Zeek for network logs. We also instrumented the workstations with Carnegie Mellon's Ghost framework. That allows you to create what they call non-playable characters, or NPCs. Essentially, those enterprise workstations on their own are writing each other emails, going to websites, opening up Office and creating documents and saving them. And they'll do that all day long. We wanted that so we could generate background noise in both our endpoint and network logs, because we also stood up in a separate network enclave an attacker environment with a simple Cobalt Strike command and control and a separate Cobalt Strike attacker workstation, where we would spearfish one of the users on those machines in the enterprise environment, let them download a malicious macro-enabled Office file, and then that would have payloads that would escalate privileges, and then execute some Mimikatz to do DC sync to the domain controller, generate a golden ticket, and then eventually access a data store and exfil data from the victim network. We wanted all that so that feeding all those logs into our SIEM, we could test out the detections that we wanted to use for finding these behaviors. Because while they can be high false positives, we still wanted them to be somewhat useful, and also wanted to test our correlations before we shared an example with the community. So we did all that and have loaded that reference implementation up on our GitHub. We also have a separate reference implementation that we just recently built for this previous Tuesday's CASP Plugfest. That's on the CASP repo right now, but we are working on some updates to the IoB repository to have that information as well. So when we want to analyze these, though, there's been a lot of handy tools out there, but we didn't want to use a TIP, our threat intel platform, for our analysis effort, because the TIPs will modify, well, not modify, but we'll try to map intel to their own data models. And we wanted to investigate and query and manipulate the STIX object itself, but have it in a little bit more analyst-friendly interface. So for that, we used Neo4j graph databases. And to convert that, we ended up developing and open sourcing a Python script that will convert any STIX 2.0 or 2.1 bundle into a Neo4j graph database, including the SROs, as well as the inferred relationships from the objects. And we've used that pretty heavily in our analysis. I'll show you some visualizations from it in a moment, but we thought that could be valuable to the community. So that's also on our repository under an Apache 2 license. And happy to receive feedback on it. And just want to make sure you guys knew about it and had access to the link. So this would be the graph visualization of one of those behavior bundles. And essentially, the dark blue here will be our behaviors with their references back to light blue, which is an attack pattern. And I'll show a little bit more detail in just a second, but we share the chain of observables we used in developing these behaviors, as well as detections in red, and in this example, a correlation object in pink. I didn't include one yet for the security playbook, but we will update with that. And the behavior object itself, you can view the Neo4j, we can view some of the metadata. There's also a description field that I actually had cut off this slide that will give you a short narrative of the behavior that's being searched for, as well as identifying the techniques that are used. And that can be, by itself, not all the super valuable data, but it comes back to the context and relationships we share. We include a set of cyber observables. Some of them do have extensions to capture a little bit more data because we wanted to help share the type of things we were looking at when we came up with the behavior and its detection. And then, so then in our detection object, the way that we stay somewhat analytic agnostic is essentially we share the analytics as base 64 encoded strings because we wanted to preserve formatting, whether you used Sigma YAML or a stick shifter query that might go inside a Jupyter notebook. We wanted to make sure that whatever you want to use, it was preserved properly. And so we encode it in base 64, and we'll cite our data sources. And also in our next update to the reference implementation, we'll be including detector objects as well, because we found that some members of our community are taking this concept and using it for some areas that we hadn't thought of, namely autonomous cyber agents. And so they want ways to tell automation how to build a detector or how to combine different tools to create a detection on the fly. And so we'll be including that in the next revision that should be coming out this summer as soon as we get everything through our public release process. But for our examples, we've used Sigma pretty heavily. For those not familiar, Sigma is a standardized format for queries against multitude of seams with a nice set of open source tools to rapidly convert it into a bunch of different environments. Additionally, we have the correlation object in our reference implementation. We're using BPMN. We've also been working on one with Cacao, but right now, the one that's on the GitHub of the second is only in BPMN. Some of this work started well before the Cacao spec was out, and so we've had to use multiple formats. But it's a way that you can, essentially, if you decode the BPMN, it's XML format, and then open it up with an open source editor like Camunda or Visagi is not open source, but I believe it's free. There's a few different editors out there, and you can inspect the correlation logic. We use this in our examples to build SOAR workflows to run the correlations, and then based on how tight the correlation is, we will trigger response playbooks. But these could be run manually if one wished, but we're trying to design them to make it easy for people to understand the logic and build their own automation or have their vendors or MSSPs build automation for them. And so we want to take advantage of standards to help take some different approaches to the type of data we can share. And IoB is one of our areas that we're heavily focused on here at the lab, and grateful to partner with the OCA and CISA and all of the good folks at Oasis. For more information, you can go to the main project page. We also have a nice technical video. It kind of takes you through the concept and shows you different aspects of it. And then the GitHub is where you'll find all the documentation, reference implementations, and code. So with that said, we have about 5 minutes left. I'll stop sharing and happily answer any questions. So thank you for your time.
Hi, Charles. It's Terry here. I got a question about what the plans are for the indicators of behavior work. Is your aim to get this merged into the standard eventually? Is that the plan?
Yes, sir. Thank you for asking that, because due to the joy of time zones, I forgot to say that at the beginning of my talk. And but yes, we've been working across the Open Cyber Alliance in general, or Cybersecurity Alliance. Several of the projects have been working on some custom objects and extensions. And so we've been looking at, with the OCA technical committee, to submit a set of proposed extensions to the CTI repository for consideration and potential inclusion in a new revision of the standard, or at least to be in the documented set of extensions and objects.
Okay, that's really cool. Another question I have is, do you have a publicly accessible library of behaviors? So I'm thinking that if attack people have their particular set of taxi server, that's kind of, I guess, the reference. I know in the past I've been trying to work towards the same sort of thing with the CVE first community to try and get a standardized set of CVE objects. So is that something that the OCA are looking at as well?
Looking at, yes. We don't have it yet. And I will say we here at the Applied Physics Lab are working on a few tasks and pilots to help us build some of that out, as well as looking at tooling to make it easier to create the behavior objects. It is a long process, and we are working to get towards there, but we don't have a library of known behaviors yet. So we've focused heavily on the construct rather than the content yet, because we're going to need a lot of help.
Yeah, because longer term, it would be really good if there was something that a certain group operated, where that's OCA itself, and then of course ensuring that there was that alignment with the attack objects that are done by that team. I'm always thinking in the back of my mind about how to make it less onerous for the consumers of this information, and if we have a really strong points of pivoting within the data model, then that's always something that can help.
Yeah, one area that I think's got a lot of potential is we've been talking several times with MITRE Ingenuity's Center for Threat Informed Defense, and we really think that attack flow could be a really good tool to help standardize the linkage between the behaviors and the sequence of attack actions. And we've done some example. We've made some examples right now. They're very excited. They were very excited about it. I don't have any more news to release on that, but we are still exchanging data and looking at ways to integrate those together. Because to me, that's the natural step. Because attack flow shares a human consumable narrative very well, but we feel that mapping those out to the behaviors will make that a lot more repeatable, and also allows us to throw in the detections and correlations.
Absolutely, yeah. It's that joining together the attack side of things with the defender's perspective it's absolutely so critical, and so any sort of alignment that you guys can get it there is just going to be so helpful for the greater community.
Yes, and so that's you just laid out my entire roadmap.
Excellent to hear.
All right. Are there any other questions out there from the group?
Yeah. So again, this is really cool stuff. So I've been working pretty heavily on Sticks incidents and events, and basically getting it so we can record the chain of what happened. And I was just trying to make sure. So is the behavior what happened or what we believe happens, and then we have the pattern to trigger against what's there? And that's
Yeah, the behavior is what we can observe on the victim network.
Yeah, so it's an indicator, effectively. Is that right, Charles? It's something to look for, not something that we've seen.
Yeah, that's what we call them. Which is why
cool.
we call them IoBs, just because, they are an indicator, but unfortunately, over the past few years, indicator by itself has kind of gotten a different interpretation.
I basically have got on log rants about atomic indicators.
I'm right there with you. I think I've squeezed every bit of utility I can out of them, and there are times when I get some value, but in general, I'm very disappointed a lot of times if we share, especially if we share things like C2 IP addresses in threat reports, believing that those are going to still be active.
We got them, guys. We got them. We blocked the IP.
Yeah.
We're safe forever.
So Jeffrey, I've got a question then for you. So do you is the indicators of behavior, is that something that would fit quite nicely with the event object?
Yeah, so yeah, that's kind of where I was just clarifying to make sure there wasn't overlap. But in this case, it's actually in my mind a perfect synergy. So
Yeah.
because events can do sub-events, so what you could actually break out, which is really cool, is you can have a top level event, which is a citing of a behavior. And then within, say, here are the sub-events, which is the chain of literally everything that happened, which are the things that the behavior triggers on. If you can get to that level of detail of here's when, and here's the sequence it went, and that was what the behavior triggered, and basically break down effectively that whole chain for that detection, which is really neat for me.
Yeah.
Yeah. So how does that work with sightings though? That would be the only thing. Like sightings at the moment, we have the ability of, I guess, if there's lots of different sorts of events, we can only hook up some of them. How does that work?
I would say you would do sightings off the correlations rather than the raw detections. Just because some of them, I don't think anybody's interested in the number of sightings or how many times a macro-enabled Office file was downloaded, because that would, I think we'd all glaze over on that. But when I can show that a downloaded macro-enabled Office file spawns some bizarre child processes, when I can correlate those together, I can share a citing of that behavior sequence.
Yeah, and
how does that work with event objects then? Jeffrey,
so an event has a optional list of sightings that basically reference and trigger it. Originally, we're trying to model in a few different ways, like directly going to attack patterns and the like, but in order to try to keep things as consistent as possible, we consolidated with you go to the citing, and then you have a citing of an attack pattern, you have a citing of now an indicator of behavior, a citing of a malware, and you can have an event composed of dozens of different sightings of things, and those sightings can have observables tied to them. But what's kind of neat for sightings for me is, unlike observed data, you don't need to even tell them the time. You can give them the time window, you can give them a count, but you don't have to. So you're able to redact really well.
Yeah, I really like that indirection, because that then gives us the flexibility for adding in IOBs in the future if we need it. Oh, love it.
Yeah.
And like I said, I encourage you to take a look at the reference implementation, because I will say, in my opinion, some of the way we're doing detections is when you first read them are a little strange, but that's because we're really building detections for feeding correlations. Like, as a simple example, when I want to detect privilege escalation, I stare at sysmon logs and I fire off an alert anytime a system level process was spawned by a user level process, which is a really dumb analytic as far as its simplicity. But anytime the owner of the parent doesn't have a $ in the user ID, and the child is owned by something with a $, then you have user level spawning system level. And I'll be honest, I don't get that happening by accident very often. But that alert by itself isn't something that we would trigger off the SOC. We can then feed off that the processes related to that to see if they're connected to other behaviors, the user account, and see if that's related to other behaviors, as well as the system, and some time-based windowing as well. We can share in the correlation logic so that your automation can see what's common on some of the other alerts. And
so, Charles, just for clarification, is the correlation, is that the sequence of events? That's the set of this thing followed by this behavior followed by this behavior. That's known as a correlation within your terminology. Is that correct?
Yes, sir.
Okay. Yeah, and I found that a bit confusing.
Oh, my apologies.
Naming.
And when we share the decision logic, we've tried to design them so that it doesn't have to be, it doesn't by no means has to be linear. It does not have to be. Any one detection can trigger an automation workflow to search for the detections to correlate against. And that's kind of how we've gone about it, so that you don't have to capture every single step of the chain to have a correlation, so that you can have kind of low, medium, and high confidence that you've correlated malicious activity.
Okay, actually, that's a good point. So it has confidence levels as well within the objects.
Essentially, I mean, we have a maximum amount of common fields you can correlate, and we generate a message set to the analyst stating this was the X out of Y potential correlations matched for this sequence, and
Okay.
so kind of let the receiver decide what their threshold for low, medium, and high confidence would be. There are a few things that we've talked about that might be recommended triggers regardless of the correlation. I think if you get, if you have an analytic that you strongly believe represents DNS beaconing for exfiltration, you probably don't want to wait for a correlation to take some action, most likely. And so we've been working on that too, and how to flag triggers that could fire midway through a correlation workflow, as well as once the correlation occurs.
Yeah, I mean, you could, for something like that, you could always just have a correlation with that one thing in it anyway.
Yes.
So,
Yeah. At the same time, we really hope that unfortunately it does happen a lot, but we hope that that's not the first time we detect the abnormal activity.
Yeah. Cool. I'm out of questions. Thanks, Charles. And thank you, Jeffrey, as
absolutely.
well.
Yeah, this is really, really cool stuff. And I was curious for your behavior patterns. Do you allow cycles, or is it acyclic?
It does allow cycles, but there is some logic normally to keep it from going into a nonstop loop.
Okay.
That makes sense.
Yeah.
We kind of give it little sanity windows of how far to look out so that it doesn't be a never ending, because the early research, we had that problem because one of our threat emulators had a little mix up on a script and kept sending the attack nonstop for about a week. And so
yeah, fair. And yeah, it's at least like as we've been going through some of the event stuff and how you record sequences when they happen. It's interesting, like acyclic. Okay, actually, no, you need a cycle. Okay, but how do you tell them where it start? Okay. So. Yep.
And so, yeah, and I should have said earlier, a lot of this work was inspired by another project known as Mosaics, which is a security orchestration task for industrial control systems. And they had the same problem when trying to measure ICS system integrity. And so they started looking at ways to correlate alerts and sharing the correlation for a bunch of different ICS related SIEM alerts. And that got us thinking, well, the sharing correlations is a lot more powerful than sharing detections. And that kind of led to all this. We've been working on this for about, I'd say, completely started working on it 5 years ago, but there've been a few events, especially during COVID, that redirected our team on a few places. So.
Yeah, it's again, very, very cool stuff. And yeah, really happy to see this.
Yeah, thank you so much for sharing.
Oh, always happy to.
Yeah, thank you, Charlie. Really appreciate it. And glad that is well received. I anticipated that for a lot of the CDCs moving forward, the community dev corners moving forward. So these are the kind of things that we'll be looking forward to within our CDCs. Trying to, for right now, as I mentioned earlier, trying to bring awareness to some of the other efforts that are going on, seeing if there's any synergies, seeing how we can impact other efforts, seeing how other efforts could impact us. I think a lot of this will allow us to have a wider aperture and awareness of what's going on, and then the ways that we can better position ourselves in the work that we're doing to help the larger ecosystem, whether that's developing something specifically within the CTI/TC, and or whether that is contributing to something else that's going on out there for the better of the, like I said, the overall ecosystem. So with that, I'd like to thank you, Charlie, for coming and showing us the work that you're doing within IoB and letting us get a better understanding of its correlation to the work that we're doing here within the CTI/TC. And I'm glad that we have some synergies going together, and looking forward to the value that IoB is going to be having moving forward, and any extensions that you may bring over to the CTI/TC. And if there's things that you identify within sticks as you guys are working on extensions, anything that you need in regards to help with like, hey, how should we bring this over? What's the process? We have documentation on that, or other things that you might see that might be gaps within sticks or taxi today. Feel free to let us know. We'll work on those with you.
Fantastic.
All right. Thanks, everybody.
Take care.
Thanks, Marlon. Thanks, Jane. Thanks, everyone.
Thanks, everyone.